Thank you, John. And I want to thank all of you. This has been, y'all are fun. Y'all are fun to be around. This has just been really good. And I'm sorry it's all science, and y'all just barreling through all that, which I did really well, and I really appreciate that. And so y'all are just a great congregation, and I just love being around you. Thank you to John and Earlene for taking care of me this weekend, and I appreciate them as well. That's the thing. There we go. I need to get situated here. Okay, can y'all take one more talk?
Yes, sir.
Okay, we're going to try to do this, all right? Here we go. Y'all know Genesis 1. In the beginning, God created the heavens and the earth. The earth was without form and void, and darkness was over the face of the deep. And the Spirit of God was hovering over the face of the waters. And God said, "Let there be light." And there was light. And God saw that the light was good. And God separated the light from the darkness. And God called the light day, and the darkness he called night. And there was evening and there was morning the first day. And God said, "Let there be..." You know how many times he said, and God said? I don't know. I'll tell you in a minute here, all right? Genesis 1, written to give us a description of God, of how powerful he was, what he's all about, what he can do. The word for God here in Genesis 1, y'all know there are several words for God. This one is Elohim, which has actually two different parts to it. One, God's power and might, and two, that he has complete creativity. And if you've seen all these programs on all the different organisms that God made, he was pretty creative. Yeah, he is just real creative. Look at us. He's pretty creative there as well. Elohim is stated 32 times in chapter 1, showing God's creative power in making his creation. I put it on the BBC nature presentations. I watch those all the time, and they're just incredible to see all the different things that God has made. He said, in Genesis 1, it says, God said 9 times, "Let there be. Let there be light. Let the waters be divided." Yeah. All 9 times he said that. A lot of people are wanting to play down Genesis 1 as not really being part of God's, what actually happened, that it's just a story. But I want to tell you, it's confirmed in other books. In Psalms 33:6, "By the word of the Lord, the heavens were made, and their starry host by the breath of his mouth." All he had to do is just open his mouth, and all the stars were made. Do we have a powerful God? Amen. Hebrews, in the New Testament, 11:3. "By faith we understand that the worlds were prepared by the word of God, so that what is seen is not made out of things which are visible." Genesis 1 is real. We have a very creative God. In John 1, in the beginning was the Word was with God, and the Word was God. He was in the beginning with God. All things were made through him, and without him was not anything made that was made. In him was life, and the life was the light of men. So both Old Testament and New Testament both agree about the creative power of God. So can I show you a little bit about God's creative power this morning? All right, let's have some fun this morning. This came out in Science magazine, September 13, 2013. This jumping insect has, did y'all see it? Gears. There they are. Isn't that amazing? He has gears. His hind legs have gears that work. And so he moves those gears. I'll show you a little bit. There you go. He moves those gears. He cocks them to get ready to jump. And then when he jumps, and both legs goes. But the gears make sure that both legs move at the same time so that he can go in just the right direction that he's going. If he didn't have those, he might go this way when he jumps or this way, but he can direct exactly where he wants to go. Is that not cool? It's got gears. Even National Geographic, when they were writing about that, the writer said, "This insect has gears, gears." Why is that so amazing? Because it's pretty plain to see their function, right? Yeah. Where do you normally see gears? Yeah, in a car or in a machine shop, you see gears. It's design. It's showing design. Now, in biology, we know a little bit about the brain, but we don't know a whole bunch about that. And we don't know what all is going on up there. But when you look at gears, you know exactly what they're doing up there. It's very clear there had to be an engineer. Your eyes. It's really funny in eyes. No, it's not funny, it's discouraging. Well, it's kind of interesting. In biology, you know when they talk about the eye, they talk about how imperfect it is. We have an imperfect eye. We've got a blind spot back there. And they say, now in the textbooks, they're actually saying a creator would have not made an imperfect eye. They're starting to attack God in the textbooks, which is just so interesting because that's never happened until just the last 10 years. They've actually been saying what's wrong with the creator. And so, but the eye works really, really well. And I want to tell you about this. This is in, I had no clue. Yeah, PNAS, the journal of PNAS, back in 2007. There's Mueller cells in your eye. Now, these are fiber optic fibers in your eye. Did y'all know y'all have fiber optic fibers in your eye? It is just really, really cool. This is the back of the eye. So imagine the front of the eye is way up here, light's coming in, and it hits the back of the eye. When that light hits the retina on the back of the eye, that light is detected by rod cells and cone cells. Y'all learned that in junior high, right? Rod cells and cone cells in your eye. Okay. Well, those rod cells and cone cells are down here. They are down here in the retina. So the top of the retina is up here. That's on the inside of the eye. The light strikes right here, but these rod and cone cells are all down here detecting the light. But you've got these fiber optic cells called Mueller cells. And they go all the way through and direct the light to the rod and cone cells. This article, listen to what it says. They serve as wavelength-dependent waveguides. So they will shuttle the green-red light to the cones, and they'll pass the blue-purple light to the rods. So they're taking this light and the object that it's representing down through all that material, the different cells, but they shuttle it to the right cell so that you can actually see better. It increases photon absorption, but it minimally affects the vision mechanics by the rods. So it actually makes you see better. Isn't that interesting? I just think that's the most interesting thing. Here's the research they've done on it, and they can show the light going through all these and looking at that. So each cone cell has its own fiber optic Mueller cell. You got millions of those cone cells in there. They got their own one. It actually improves daytime vision, and it doesn't hurt nighttime vision at all. And so it seems to be a design feature. And that's what we see in God's creation. We always see this, a purposeful arrangement of parts. I mean, there's a lot to make that eye work. You've got the cornea, you've got the lens, you've got everything in there making this eye work. You've even got fiber optic cells. A purposeful arrangement of parts, which indicates there had to be a designer. This is about a bacteria. This is in PLOS Biology, that particular journal in 2016. These guys were looking at this bacteria, magnetotactic bacteria. Isn't that a cool name? I wish I had a name like that. Magnetotactic, that just sounded really, really cool. Yeah. So, but this particular bacteria, and there it is, it's just a single-celled organism. There it is. This is an electron micrograph of this organism. What's really cool about this guy, he makes his own compass. You see these dots running right through there? And these dots running right through there? He makes his own compass. Those are made out of magnetite. And he's got a protein called MAMO. Where's the MAMO? There it is. MAMO is a protein. And so this MAMO protein, he builds these magnetite nanoparticles by this protein, and it navigates Earth's magnetic field as a reference using these little things. So there's MAMO, that's a little protein, and it takes the iron out of the environment and places those iron molecules just right in there to make a magnetite cell. He puts a membrane around it, then he lines them all up, and he's got a compass. Is that not amazing? Just a little single cell bacteria making its own compass. It's just amazing what it does right there. And so it's several parts put together to do that, but it's under sophisticated control. They even know the genes now. There's about 12 or 15 different genes that are involved in making that nanoprotein, which just puts those iron particles right where they need to be to make this magnetite. It's just amazing. This is another bacteria. It glides. Now, most bacteria have a flagella that just spins, and that propels them through the water. But bacteria on surfaces have to move a different way. So this bacteria, this is in Current Biology in 2014. Look at this. He's got helical tracks and motors that run along the track. Look at this. There is the bacteria right there. It's a single-celled organism. So these motors run along this track and go back up to the front, and then they take another track and come this way, and these motors, as they're moving on that track, they push against the bottom part of the bacteria, and it secretes a slime onto the surface, and when it pushes against that, it moves it. And so it's got all these motors that are pushing down and moving, but they're running along the track inside the bacterial cell. Is that not cool? That's just one of the coolest things. Just a track running through all there. There's another bacteria that does the same thing. It's got these tracks that are running along through there, but its proteins, they rotate. And so their proteins, as they're moving on that track, when they get down to the bottom, they rotate and they go like this, and it moves the bacteria. Isn't that amazing? Are y'all seeing, this looks like a rock and pinion gear system if you're into car mechanics, that's what it looks like. Are y'all seeing a purposeful arrangement of parts? That indicates design. All of those parts had to be there at the same time together to make this thing work. Otherwise, it would have died and never gone anywhere. That indicates design. This is Flavobacterium, gliding bacteria. It all works along the same way. It's got those tracks in there, but in this way, in this particular one, these particular proteins rotate and it moves those little fibers that are sticking out of the bacteria, and as they move the bacteria along. Isn't that cool? Each organism has its own mechanism for movement in this bacterial world. Each organism. Each one of them is designed just a little bit differently. Multiple, complex, well-coordinated parts. I'm going to say it again. And sophisticated engineering. That indicates design in all of these. Now then, this is in Proceedings of the National Academy of Sciences in 2012. This particular bacteria has 7 flagella that come off of it, and that propels this bacteria. 7 flagella. But they all move the same. You know how they move the same? They took all these pictures, and you can see all these little things right there. If you look inside there, where the 7 propellers are attached, they move by gears. Wow. There's gears in here so that they all move exactly the same, so that it propels that bacteria the same. Where do you find gears? Somebody designed them in a machine shop. Yeah, that's what it is. That indicates it had to be designed by some kind of engineer. This is a mycoplasma. Now, a mycoplasma is a single-celled, it's not a bacteria because a bacteria has a cell wall. It's just a single-celled organism that doesn't have a cell wall. And so it's kind of mobile and kind of moves around. But look how it moves. It moves, they call it the centipede mechanism. You see the legs right there? Each one of those, they blew it up here, has all these proteins working together. It's got a foot that comes down and whoops, and that foot reaches up, sits down, pulls it. Isn't that amazing? Yeah, that is a machine working to make that thing work. Are y'all getting the picture? Yeah. These guys are individually made just for themselves with multiple parts working together. Had to be a designer. And so, purposeful arrangement of parts. These are what we call irreducibly complex systems. That just means that you can't reduce them. If you take away one part, the whole thing falls apart. We see that everywhere. Irreducibly complex systems. In fact, Michael Behe, who wrote that book, Darwin Evolves, he's the guy that made that term, or termed that for all the systems that are working in our body. So when we look at life, he actually says in his book here, this is his quote. So what have our powerful new tools shown us about the physical basis of life? the details of studies fill libraries, but the overarching picture is one of fathomless elegance. Who could do that? Had to be a creator. Can I show you the orchid? Now let's get away from bacteria. Let's look at the orchid. This is the Madagascar orchid, that name. I'm not going to try to say it. Y'all can say it if you want to. It's an epiphyte, which means it just sits on a plant. It's in a forest, probably a tropical forest, and it just sits on a plant and uses that plant as support. Now when it rains, it'll gather water from the rain, but it never hurts the plant that it's sitting on. It's just an epiphyte. That's what it is. But this orchid is really interesting. There's the flower of the orchid, and it's got this really, really long, what do they call it? Spur? A spur, yeah. A really long spur that's 11 to 16 inches long. And at the bottom of that spur is some nectar. Really nice nectar, good tasting nectar that's irresistible to a moth. Guess how he gets it? He has got a proboscis that's curled up, that is about 16 inches long, and so he just uncurls that dude and sticks it down in the flower. So there you can see his proboscis is really long, and it matches the long spur of that orchid. So when he goes, he flies into there, he opens it up, and it goes all the way down, and he gets his nectar down at the bottom. But while he's there, guess what happens? He gets pollen on his nose. And then when he goes, he's pulling out right there, you see him pulling out, he'll go to another flower and pollinate the other orchid. Orchids have to have something take pollen from one orchid to another to cross-pollinate. And so these insects do it. Does that look like a design to you guys? It does. Isn't that cool? This is one of my favorites. This is the hammer orchid. This hammer orchid is down in Australia. This is the orchid. This is the flower. But then it's got this part on it. Does that look weird to you? Yeah, it looks weird to me too. Now then, there's also a thynid wasp that pollinates the orchid. There he is. That's the thynid wasp. But you only see the male. You never see the female. You never see the female wasp because she lives in the ground her whole life, except one day a year. One day a year, she will come up out of the ground, she'll climb up a plant, she'll release a pheromone to attract the male. The male will come, mate with her, then she goes back down in the ground, lays her eggs, and stays in the ground until the next year. She only comes out of the ground one time a year to do that. Isn't that interesting? So, this orchid, it, at the same time this female comes up out of the ground, the orchid releases a pheromone, the same pheromone. It attracts the male thynid wasp, and this part of the orchid, I'll go back, that part right there, that looks like the female of the thynid wasp. So he tries to mate with this, in plant world we call that a dummy female. He tries to meet with the dummy female, which is part of the plant. That is a hinge. That thing hinges and brings him around and dusts pollen on the back of the thynid wasp. When he figures out nothing's working here, he flies away. Another plant releases a pheromone, attracts him. He tries to mate with the dummy female and brings the pollen around and pollinates the flower. Isn't that crazy? Yeah, there you can see it. See how it brought him around and dust pollen on his back right there. This is the only way this orchid is pollinated. How do you get a plant, I'll go back, how do you get a plant that has this thing on there, a dummy female, just the right distance between all those, a hinge there with just the right torque that'll bring him around to do all that and pollinate? How does that come about? It has to be by design. Is that not cool? This is the mucuna flower. It calls bats. It is pollinated by the bat. You know bats are nocturnal, so it's at night. But they have special parts that match each other. So this is a flower right here. Now on the flowers, I don't know that you can see them. This one's already opened up. This one's already opened up. This is what they look like before they're open. They have a couple of petals there, and those petals kind of open up like this. and there's a slit between the two petals. Now those two petals act as disc that the bat, what does he do? Echolocates off. Yeah, echolocation. So he sends out his signals, and those two petals serves as the big dishes that he echolocates off. There's a slit right in the middle that releases this pheromone, attracts the bat. And so the bat comes, I'm not sure I can see you. The bat will come, and he will hit that flower right between those two dishes, go in there, and what that does, the bat's flying from this direction. He'll hit that, and when he does, in this part of the flower, I'm going to go back, see this part of the flower right there? In that part of the flower, when it opens up, it drops down the female part, and then all these male parts it's got pollen on. So when he hits that flower, it brings his rear end around, and all the parts drop down, and it dusts pollen on the rear end. Isn't that interesting? And then he'll give his pollen, and he'll fly away. He's got pollen on his rear end. He'll go hit another plant. It'll bring him around. The female part will drop down, and he fertilizes that flower. Isn't that amazing? Yeah. There you can kind of see it a little bit. You can see his long tongue there going to get the fire. But when he brings him around, he's only about a ½ inch long, this little bat. It drops down the flowers and drops pollen on the rear end. Isn't that cool? How does that work? How do you get a plant that's just the right size, that has the triggers that when a bat hits it, it drops the pollen onto the rear end of the bat? How do you do that? It has to be a design. You can see each species has its own mechanism of sexual reproduction. Purposeful arrangement of parts, specified complexity in all of these systems. That's what we read earlier. God designed all of this to work. He created all of this, and he made it all. We've already looked at those verses as well. This is one of my favorite verses. If you're in my classes at LCU, you have to memorize this verse. It's in Romans 1. For what can be known about God is plain to them, because God has shown it to them. Ever since the creation of the world, his eternal power and his divine nature, invisible though they are, have been clearly seen, understood through things he has made. So all you have to do is just look at what he's made, and you can understand and clearly see his eternal power and his divine nature. Isn't that kind of what we saw this morning? Yeah, that's kind of what we saw. So in Genesis 1, it does say God said, but it also 7 times says God saw that it was good. It was good. What God made was really, really good. God saw the entirety of the universe, what he had made. He examined it. He judged everything about it. He looked at the finished product. He saw its nature, investigated its nature. He saw all its properties. He saw what it could do. And with all of this, he said, that's good. That's good. And he even looked at us, the crown of his work, and he said, that's very good. He made us very good. He made us in his image. He made us to take on his properties. And it was good. God has always wanted for man to have good in their lives. Always wanted that. He wants us to have good in our lives, doesn't he? Yeah, he wants us to have good. I need God's power to work good in my life. Haven't we seen that in all the people in the Bible? Yeah, we've seen God taking lots of people who were just kind of broken people, like Joseph. He took Joseph, and Joseph was hated by his brothers and sold and went as a slave in Egypt. But did God make good from him? Yeah, God made good out of his life where he helped the whole nation of Israel. Moses didn't want to do what God wanted him to do. He was afraid, but God made good in his life, where he led the people out of Egypt. Right? If you even look at Paul in the New Testament, Did God use this man who was persecuting the church, changed him around, and he became one of the greatest church planters that ever was? It was good in his life. God has always not only made things good, but he's always wanted good in our lives. Are you letting God produce good in your life? Is that your life of making things good for everybody else? I need God to declare good in my life. I can't do it on my own, but I do need to show his character in my life. Didn't he do that with Timothy? Yeah, Paul said, Timothy, with your speech, with your conduct, with your purity, everything, be an example of God's goodness. And that's our job. We can look at creation, which we've done all weekend, as you said earlier. We've done that all weekend, and what God made was good. And it was clear. I had that go on in class all the time. And it was clear. I usually do a dance, but I'm not going to do that today. It was clear that God created everything. You see all these purposeful arrangement of parts, it could only mean there could be a designer. For evolution to do that, it doesn't work that way. Evolution's never shown anything. We've seen a little evolution of broken genes, but that's all we've got. Mainly, when you look at every organism, there's something unique about it that just shouts, there is a God. And so I hope you all have been encouraged this week by seeing God as our creator. And we can trust Genesis 1, 2, 3, all the way to 11. We can trust all of those. Those are true. There's evidence of that in all the world. Don't lose your faith over evolution. It's not working. It's just not working to do. Thank y'all for being such a great audience. Y'all have really done well, and I hope God continues to work good through